This is the memory chip industry. And the pattern you're looking at, it's not a glitch, it's not bad luck, it's the single most predictable boom and bust cycle in all of technology. And it's played out on near perfect repeat for 30 years. Prices spike, companies make obscene profits, everyone overinvests, then supply floods in, prices crater, and billions get wiped out. The same cycle repeats after that. But right now, in 2026, the data looks unlike anything the industry has seen before. And the question is this genuinely a new era? Or are we just in the most dangerous part of the same old story? Stay with me, because by the end of this, you'll have a complete framework that most investors, analysts, and tech watchers are completely missing. Let's get right into it. First, what even is memory? Because when most people hear memory chips, they think of the RAM inside the laptop. But memory semiconductors are everywhere. They're inside your phone, your car, your smart TV, every server rack and every data center running every app you have ever used. There are two main types. First is dynamic random access memory, or DRAM. That's the fast temporary memory that processes things actively. Think of it as your device's working memory. It's what's running right now, in the moment. And the second type is called NAND flash, the storage that holds data when power is off. That's your photos, your files, your apps, sitting on your phone or your laptop waiting to be opened. Both follow the same brutal cycle, but we'll be focusing on DRAM because this is where the cycle hits the hardest. Now here's where it gets interesting. Three companies, Samsung, SKHynix, and Micron Technology, control about 95% of global DRAM production. Just three. And the entire world's supply of this critical component depends on them. You'd think that level of concentration would make the market stable, right? Wrong. And this is where I want you to pause and think about why. Because building a memory fabrication unit, which is essentially the factory to manufacture memory chips, costs about $15 to $20 billion. It takes 2 to 3 years. And once it's built, you run it at maximum capacity. Because the fixed costs are so enormous that slowing down actually costs you more money, not less. So here's what happens. Demand goes up, prices spike, all three companies look at the same signals, make the same bets, and start building at the same time. Then 2 to 3 years later, all that new supply floods the market simultaneously. Prices crater and everyone bleeds. But if they know this keeps happening, and they do, it's been 30 years, why can't they just not do this? The reason becomes obvious when you look at actually what happens inside one of these cycles. Let me show you one of the most vivid examples of this cycle in modern history, the 2016 and 2020 cycle. And I'll take you through the journey of one of these three companies so that you can actually feel the numbers and not just see them. So in 2016, Micron Technology's revenue was $12.4 billion, with an operating margin of 1.4%. They're barely alive. The memory market had just been through a brutal pricing war, and analysts are writing obituaries. Then, something shifts. Cloud computing explodes, smartphones start needing more memory, and all the three memory giants happen to be retooling their factories at the same time to build a new generation of flash storage, quietly squeezing DRAM supply just as demand surges. See, the thing is, nobody engineered the shortage. It emerged as a side effect of chasing the next thing. Then, as you would expect, demand outpaced supply and the entire cycle flipped. By 2018, Micron's revenue was $30.4 billion and the operating margin increased to 49.3%. Nearly 50 cents of operating profit on every dollar. A company that was barely surviving was now one of America's most profitable businesses. And then the clock ran out. The capex that got approved at peak euphoria for fabs which took 2 to 3 years to build all started coming online at once. Now that new capacity was arriving simultaneously into a market where demand had already started to plateau. Prices crashed and things started to go south from there. By 2020, Micron's revenue fell to $21 billion and operating income had collapsed 80% from peak. Then came the COVID cycle, which gave the industry a brief artificial reprieve. Remote work, laptops, cloud, everybody was buying memory again. Companies overordered to secure supply, and manufacturers ramped back up. And then, just as predictably as every cycle before it, the demand vanished. By 2022, inventories piled up across the entire supply chain, and the floor fell out. In fiscal year 23, Micron made a net loss of $5.8 billion. That's the memory bust in its purest form. And here's what's important to understand. This isn't a 2016 story or a Micron story. Every cycle that came before it, be it the Windows PC cycle in 1993, the dot-com build-out cycle in 2000, or the smartphone early cloud cycle in 2008, all followed the same surge, the same overbuild, the same crash. Samsung, SKHynix, the whole industry follows this curve. In each case, the demand driver changes. The response never does. So back to the question, why can't they just stop? Why does this keep happening when everyone can see it coming? Two reasons. First, coordination is illegal. It was tried once in the early 2000s. The Department of Justice prosecuted, and Samsung paid a $300 million fine. And even if it weren't illegal, the economics of running a fab forbids it. So everyone builds, everyone floods, every single time. Not because they are stupid, but because they have no other rational choice. It's a trap built into the structure of the industry. Right now, in 2026, we are in a massive upcycle, unlike anything the industry has seen before. So does that mean an impending downturn is just around the corner? Let me give you the current picture, because the data is extraordinary. DRAM contract prices surged nearly 170% year over year through Q4 2025, and then accelerated further this year. A 32GB DDR5 kit that cost $80 in mid-2025 was selling for about $400 by early 2026, more than a 400% increase in just under a year. Samsung was reportedly only able to fulfill 70% of its DRAM orders. Inventories at their lowest since the 2018 supercycle peak. But here's the new variable that did not exist in any other previous cycle: HBM, or high bandwidth memory. When you train or run an AI model, the single biggest constraint isn't the processor. It's getting data to and from memory fast enough. And HBM is a completely new architecture. It has chips stacked on top of each other with thousands of tiny connections, delivering data at speeds standard DRAM can't even touch. Every serious AI chip, be it the NVIDIA H100, the Blackwell, or the upcoming Rubin, all of them run on HBM. And here's the supply constraint. 1 GB of HBM requires roughly 4 times the wafer capacity of standard DRAM. You can't just flip a switch and convert existing factories. SKHynix, which holds about 62% of the global HBM market, has essentially sold out its entire HBM production through 2026. Multi-year contracts with hyperscalers. This has literally never happened before in memory industry. But is the demand really structural, or is this just another version of everyone building at the same time? Here's the argument that changes everything, and I want you to think about this carefully. Every previous memory cycle was ultimately constrained by what you might call the human endpoint. You buy one phone, maybe one laptop, perhaps a tablet. At some point, there are only so many humans and only so many devices per human. Demand has a ceiling. Once everyone who needed a device had one, the boom was over. Demand dried up, but the supply kept coming, because of which prices collapsed. But the AI era has done something no previous cycle ever managed. It changed the demand equation itself. Memory is no longer serving a fixed number of humans with a fixed number of devices. Memory, especially HBM, is now a critical input for generating intelligence. Every time you use ChatGPT, Claude, or Gemini, every search or every image generation that you make, that's a memory call, which means that AI isn't thinking from scratch. It's pulling billions of numerical model weights out of memory and feeding it into the compute processor in real time to generate the response. The faster and larger that memory, the more powerful the intelligence. In AI, memory isn't just a component, it's the ultimate speed limit. And here's the thing, if memory costs drop and the cost of running a model or inference becomes cheaper, that doesn't mean demand for inference drops. Think about what happens when electricity gets cheaper. People don't use the same amount and pocket the savings, right? They buy more appliances, run more devices, consume more. AI inference works exactly the same way. Every time the cost of running a model drops, the projects that couldn't justify the compute bill suddenly can. Cheaper intelligence doesn't reduce demand for intelligence. It creates entirely new demand that did not exist before. That's the opposite of the gadget cycle, where cheaper memory never made anyone buy a second phone. The ceiling was fixed. With AI, there may be no ceiling at all. In 2020, the top AI chip had 80 gigabytes of HBM. The next generation is targeting 288 to 576 gigabytes. That's a 7x increase in memory content per unit. That too in roughly 5 years. For comparison, PC DRAM took a decade to double, which shows that AI memory content is growing on an exponential, not a linear curve. And critically, the three memory giants know this. Samsung, SKHynix, and Micron are collectively spending around $60 billion in capex in 2026. But the vast majority is going into HBM and advanced nodes for AI, not the commodity DRAM that triggered every previous oversupply crisis. But this is where I want to challenge you. Does this mean the cycle is dead or just delayed? Now let's be honest about the risk, because this time is different are historically the four most expensive words in investing. Risk 1 is China. CXMT, which is China's state-backed DRAM maker, is expanding aggressively. If Chinese companies crack high-end DRAM at scale, the supply picture changes fast. The same thing already happened in solar, in batteries, and in legacy chips. The second risk would be a technical leap that needs less memory. What if the new generation of AI architecture becomes dramatically more efficient? Models that can run on fraction of today's memory. This has happened before in chip history, and it could happen again. And the third risk is if the monetization of AI fails to materialize, or if the economic returns don't justify the infrastructure build-out, hyperscaler capex could reverse very quickly. But the question this time shouldn't be whether there'll be a downturn. There will be one at some point, maybe. The real question is whether the thing that made every previous crash so catastrophic, the human endpoint, still exists or not. Because if AI has genuinely removed that ceiling, then the most predictable industry in all of technology has just become the most misunderstood.